Hi, my name is Patrick Desjardins, and in this episode, we will see what is a data loader and how that it will improve your GraphQL performance by reducing the stress on your backend. We will first see a quick theory on what is a data loader and then implement it on the project we have been building since the beginning of the series about having automated type generated in a GraphQL in gRPC architecture. What is a data loader? A data loader is an NPM library that you can download, which is actually a pattern that helps to perform queries by adding a cache on the fly and to reduce the amount of queries. When I say on the fly, I mean that it creates a cache to avoid performing twice the same backend query on a single GraphQL request. It means that if the application performs two GraphQL queries, that the data loader will have two instances. The data are not shared. It is important to understand that a cache is created on the query arriving to GraphQL and destroyed automatically on the response. The goal is not to share the load of the information among all the requests of the GraphQL server, but to reduce the load for a single GraphQL request to all the backend services. It is possible to have a shared cache by having GraphQL sharing information, but that is out of scope for the moment. So while it might sound like a disadvantage, it is on the other side a positive to avoid mixing user data by accident. The reason that having a cache on the fly is primordial is that when traversing the graph, each node needs information and many nodes might be the same. It happens often in a situation where GraphQL requests a model where recursive information occurs. In our example, a house has a person, the owner, which can have many houses. But for sure, one of the first house is also the house in the list of the person. Hence, we can assume that we will fetch the same information twice if we don't keep track of what we are fetching. The data loader takes care of that for you. You do not have to worry about having twice the same requests to the backend. The data loader will perform a cache on the unique identifier you configure. On the other hand, we have the advantage of batching the requests, which reduce the number of queries. The data loader library won't perform the request to the backend right away. It waits for one tick. A tick is one life cycle on the server. It is very fast, but traversing a tree is also. If we take another example where we fetch a person and it returns all the houses, which get all the person living in the house, we have a person, two house, two person relationship. Without a query reducing the advantage of the batching, we could end up having all these 6 backend queries. In one tick, hundreds of nodes can be traversed. So what the data loader sees is what we are requesting. 2 backend endpoints, get person, get house. I do not want to complexify anything, but the data loader does not perform what is called a look-ahead pattern, meaning it analyzes the GraphQL to know what is coming and choose the endpoints that could serve what is below a node. I won't get into more detail because the look-ahead pattern gets complicated when an entity can be used in many situations, which the data loader handled very well. Back to the data loader, we can see that the first thing optimized is removing the person 1 from one of the subsequent node from the root. The data loader knows it's already have a request for it. Thus, one request saved. Then it figures out that with our configuration that we are requesting 2 entities, that it is possible to use the gRPC function of the list instead. That is the reason that I mentioned in one of the former episodes of this series that it is a good practice to always have a getID and getIDs for each of your entities. Here, it is very convenient. The picture of what happened is that the resolver got called for every node of information we request in the GraphQL query. In that example, 6 nodes, hence 6 resolvers. The resolvers call 6 times the data loader to get the data and extract the field needed from the query, but only perform 2 calls to the services. Now let's implement the code into our code base. The first step is to install the library. The library is named DataLoader. It is built by some Facebook employees. You can do an npm install save DataLoader to get the library. Fortunately, the TypeScript definition is in the package. Hence, no need to get the definition file. Before going full speed, let's add some console.log into the house service and person service and do a query to see how many queries are performed. We will redo the same test at the end. I'm fast forwarding a little. Now let's do a query. We can see many requests. Alright, let's stop the toServer and go inside the DataLoaders folder. We create the DataLoaders folder inside the GraphQL folder. Then we will create 3 files, one for the person, one for the house, and one that will be a facade that will be added to the GraphQL context. The first file will be person DataLoader.ts. I create a class that I export. The class does not need to implement any interface. What it needs to do is to define function for each entity access. In our case, we will have a single function per DataLoader, or 2, depending on what we want. Normally, we will have a couple of functions per service. I like to have a one-to-one relationship with the service, not endpoint, but service. But this is a personal preference. Then let's create 2 fields of type DataLoader. We could have only one for person and handles everything here. But in the case that we have a query that has at the root that need a list of people, it makes more sense having a DataLoader to load a list and one for individual person. That being said, as we recall from the previous explanation, getPerson will be called many times and the DataLoader will fetch once by calling the getPeople gRPC instead of many times the getPerson. In the constructor of the DataLoader, I initialize the 2 DataLoaders. First, the field is an asynchronous function. We are performing a request of information to the backend API, or could be a database, which will be asynchronous, because we do not want to have the GraphQL server waiting. The DataLoader first generic parameter is the type of number. It could be a custom object with some filter information, for example. What is the first type is the input data. In our case, we fetch by ID, hence we're going to have a number field. The second type is the response. Even if the DataLoader uses a function for many fields, we define it for a single entity, in our case, a person. But you notice that we also have a union with undefined. The reason is that we may fetch for person 1 to 3 and the gRPC for 2 does not exist or fail. In that case, we still want the DataLoader to return a response of 1 and 3. To keep track of the response, the function must return each entity in the same order of the input. The reason is that we may fetch for person 1 to 3 and the gRPC for 2 does not exist or fail. In that case, we still want the DataLoader to return the response for 1 and 3. To keep track of the response, the function must return each entity in the same order of the input. If the GraphQL is traversed and get person 3 then 1, then the DataLoader must return 3 and 1 first and then 2. So the first thing to do in the body of the function is to check if we have a single ID or not. The function takes always an array since the DataLoader in the single tick can have one or many person to fetch. If there's only one, we can invoke the gRPC getPerson. We call the person service that we received by the constructor and receive a single person. We return an array with a single entity. Remember, we need them in order. The else case handles a list of person. We do not know how many, so we need to have a list of lists. The result come back, but we do not have any assurance that the data is coming back in the same order we specify in the gRPC. Hence, we need to order. I'll post a non-optimized function that take the inputs, search for the ID, and then return a list and make it in order. I built it pretty fast, and you could optimize it with a hash table or something better than traversing the array. But that is not the goal for the moment. What is important is that you understand that we must return the information in the same order as the information was requested. The function I create does not set undefined if the gRPC didn't return any query, and it should, or throw an exception. It's up to you. The second parameter of the data loader lets you set the batch to true or false. I like to explicitly always set the value instead of relying on the default value, because what is a default? I don't remember. Too many default value for so many frameworks, so let's be explicit, and it takes only 1 second. It is also possible to specify a cache key fn that lets you specify a unique identifier to avoid requerying the data. The getPeople is very similar, but we want to do something interesting called priming the data. To simplify, I will assume we do not batch, hence we'll access directly the index 0. It will simplify the readability for this example. When the batch is false, the array of input is always of 1 element, because we are handling a list of person. The first element is a list itself. The getPeople service is called, and we order the response. After, what I will do is to prime the other data loader, the getPerson. It means that if we call getPerson1 and that we never called getPerson before, but call getPeople, and that the getPeople as the result of the person1, that the getPerson will not perform the query. It will have it in its cache. This is called priming the data loader. I will fast forward the data loader for the house since it is the same logic. The next step is to create the facade. The facade is useful when you have a lot of data loader, which, as you can guess, will be the case of any system with many entities. The constructor takes the data source and pass it to the two data loader. That is the way that they have access to the gRPC. Then we need to go back in the Graphql server and initialize the data loader into the context. The final step is to go into the resolver and remove the usage of the data source for the data loader. Let's start with person_resolver.ts. The process is to call the data loader every time we see the data source, then call the getterPerson and call the function. It is important to call a load, which is the function that will invoke the function we created. A couple of details. First, we are not returning the response object anymore. The resolver shouldn't be in the business of gRPC, only the model. Hence, we can remove the call to the getter of the response. Then, we need to adjust the mapper to accept undefined because the resolver may return an undefined in case of the gRPC couldn't return a value. I'll fast forward the rest, but it's the same everywhere. At that point, we can remove from the context the data source to avoid people using the data source instead of the data loader. This can be done inside the custom context.ts. If we run our application, we will have a reduced amount of requests. And now, well, that is unexpected. We should have more than 2, but that is too many requests. So why more than 2? Because the first call requests for 1, 2, 3 houses, but after 1 and 2, and it's probably different data. The first query must be performed to get the owner, which will return a list of other houses. But that is too much. I think I know what is going on. Let's move back to the house data loader and check the get houses. We see that we do not have a cache key function, so it takes a response, which is an object, and the signature changes all the time. So let's take the input as the key. Because it's a list of number, we will join all the key with a hyphen. We need to specify the return type in the third parameter of the data loader to be string. Let's try again. Yeah, it's way better. We can continue to improve because the first call is requesting all the houses, hence we could prime the cache key 1 and 2 and 1 and 3 and 2 and 3. But I won't do it because the permutation demonstrates that the way we are building our key is not the most efficient way. To wrap up, we have seen how to optimize our GraphQL by removing every duplicated request to our gRPC server, but also how to batch data to save queries. The code remains strongly typed, and we are ready for the next episode where we will consume the GraphQL with a simple web server. The next episode will show you how to get from the custom query on the web server the TypeScript generated for you. Please subscribe to this channel to receive the notification for the next episode, and if you like it, smash that button like. Also, if you have any question or recommendation, feel free to add a comment below. Have a good day.